Welcome to Discrete Math, the fall semester of 2021. One of the requirements for this class is that you download and install Wolfram Mathematica. So what is Wolfram Mathematica? So let's go here to my Oakton homepage. Okay. And I click on My Courses. And I click on Fall 2021. And this is the discrete math class that you're enrolled in. And of course, your view will be different because you're a student. I'm an instructor, so our web pages will look slightly different. I scroll to the bottom. And notice right over here, it says Request Mathematica Faculty. Mathematica request Mathematica Faculty. For you, it will say Request Mathematica Student because you're a student. Now this is important, okay? When you click on this, you will be prompted to create a Wolfram profile. Your Wolfram profile should be your Oakton email address. You must provide your Oakton email address. If you provide a private email address like Hotmail or Gmail or MSN or something like that, msn.com or Yahoo, anything like that, then your request for the software will be denied. So you must provide an Oakton email address. Why? Because Oakton pays a certain amount of money to this company every year so that students can use the software for free. So therefore, you must provide your Oakton email address. Any other email address, forget it. Your request will be declined, and you won't be able to get the software unless you pay for it. And it's a little bit expensive, okay? So it's free if you provide your Oakton email address, which is what you're supposed to do. Okay, so let's take a look at a chapter 1 problem. All right, let's just do 2 problems, one from chapter 1 and one from chapter 2, because I don't want this video to get too long, okay? So we have a truth table here, and we have 3 Boolean values. So remember, a Boolean value can be true or false, and that's it. It's just true or false. Okay, so we have 3 Boolean values. We have P, we have Q, and we have R. And remember that each value can be either true or false. So the upside down V, or no, sorry, this is not an upside down V, it's just a V. It's just a V. That thing that looks like the letter V, you read that P or Q. P or Q. Okay? So that thing that looks like the letter V, you read it P or Q. And as long as one of those values, at least one, it could be both, as long as at least one of those values is true, the Boolean value of this entire expression is also true. So true or false is true. False or true is true. True or true is true. False or false is false. Okay? So let's see how we would do this in Mathematica, because we should use the software to help us solve the problem, okay? So let's see. I have Mathematica right over here, and I changed the font a little bit so that I think it's easier to look at. You can change the font by clicking on Format. You can edit your style sheet. That's one option. Another option is to click on Option Inspector. And there are a lot of ways that you can change the way that your Mathematica notebook looks, okay? So you can change the formatting, you can change the font to your own personal specifications so that it looks more visually attractive to you, okay? Excuse me. And if it's more visually attractive to you, then it will be easier for you to work with, right? Okay, so we have PQR. So Boolean table PQR. And then I have P or Q. Excuse me. I have P or Q. Okay. And then I have P or Q or R, and the P or Q are in parentheses. So then I have P, escape, double bar, or Q, escape, or escape, R. Okay. And then I have Q or R. I have Q or R. And then I have P or Q or R. But the parentheses are around the last two Boolean variables. So I have P or Q or R. Close my list. Okay. Comma, what are my variables? P, Q, and R. Okay. So it looks pretty good, but not quite what I want. So what I'm going to do is let's prepend this. We're going to prepend it, which means I'm going to create a row on the top. I'm going to create a row on the top, so this is a little easier to read. Okay, so it's a little bit easier to read. And these are going to be strings. P, Q, R, P, or R. Let's see, P, or, no, I'm sorry, that's P or Q. Sorry about that. That's P or Q. And that's P or Q or R. And that's going to be Q or R. And that's going, and finally the last column will be P or, in parentheses, Q, oops, or R. Let's see what that looks like. Okay, that looks a little better, but still it's hard to read. Why don't we use the grid command? Use the grid command, frame all. Oh, that looks really nice. That looks really nice, okay. And let me see, is there something else we can do to kind of spice this up a little bit? Let me see, if we were to do background, background, 1 yellow. Okay, so what I want to do, let me see. I want the first row to be yellow. There we go. And that looks pretty good. We could make that a little bit bigger. I think image size. Oh, it won't accept image size as an option. That's okay. That's okay. That's close enough. That's close enough. Okay, so let's take a look at what we have over here. Okay, so we have to finish, let's see, 1, 2, 3, 4, 5. The fifth column. 1, 2, 3, 4, 5. Everything is true except the value at the bottom, which is false. So we're going to have true, 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 and false. And then let's look at that last column. Again, everything at the bottom, everything in the last column is true except at the bottom we have false. So we're going to have true, 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 oops, that should be true, and false. Let me just make sure we're okay. So we're looking at the 1, 2, 3, 4, 5, the fifth and seventh columns. Fifth and seventh columns. Everything is true except the value at the bottom. Everything is true except the value at the bottom. And this should be good. And it's correct. Okay? So not so difficult. We could possibly, hold on one second. Let me get a little more comfortable here. Hold on. There we go. I'm at my desk and I'm just moving my chair a little bit. Over here, we might be able to do, let me see here. We might be able to do a substitution. Perhaps we can do true, replace it with the string t, and false, replace it with the string f. Let's see what that's going to look like. Yeah, so if we do this substitution, this is how you do this substitution in a list. That's how you do the substitution. So it's the /dots. /dots. And this way, the truth table that we have, it looks more like the truth table here in your homework. Because instead of true, they have the letter T. Instead of false, they have the letter F. Okay, so that's pretty simple. So one more time, let's make sure we understand what's happening here. Okay, let's say I have a list. Oh, wait a minute. No. Let's leave that alone. Okay, so let's say I have a list. My list is equal to, or actually names. Names is equal to Zeus, Hera, Ares, Athena, the names of Greek gods. So Zeus, Hera, Ares, Athena, Aphrodite, Hephaestus, let's see, Hermes, and Hades, and Poseidon, and who else? We could say Hercules, and actually I think the Greeks didn't really call him Hercules, they called him Heracles. And who else? There's Apollo, and there's Artemis, and did I cover everybody? Well, there's so many more. Hecate, and let's see. Hestia. Okay, I think that's good enough. So those are the names of some Greek gods and goddesses, okay? So names, replace Zeus with Jupiter, and replace Hera with Juno. Okay, because the Romans called him Jupiter, the Greeks called him Zeus, the Romans called him Jupiter, and The Greeks called her Hera, but the Romans called her Juno. So let's see what that does. So now we have Jupiter and Juno. However, the original names list hasn't changed. It's still the same list. So if I want to preserve those changes, I'm going to do a copy and paste. Okay. Then I have to update my variable names. And now names has been updated. Shift enter. You always shift enter at the end of your command. Okay. So that's how you do a replacement. That's how you do a replacement in Mathematica. Okay. Very simple. Okay, let's just take a look at a problem in chapter 2. Let's take a look at a problem in chapter 2. Okay, excuse me. Okay, let's see, chapter 2 homework. Oops. Okay, here we go. I want to choose a problem where I can really show you some of the power of Mathematica. Well, here's a pretty good example. Let's look at problem number 80. This is a multi-part question. Once an answer is submitted, you will be unable to return to this part. List the first 10 terms of each of these sequences. Do not enter commas for numbers greater than 1,000. The sequence that begins with 2 and in which each successive term is 3 more than the preceding term. The first 10 terms are, well, of course, we begin with 2, and then 2 plus 3 is 5, and 5 plus 3 is 8, and 8 plus 3 is 11, and 11 plus 3 is 14. 14 plus 3 is 17, and 17 plus 3 is 20. 20 plus 3 is 23, and 23 plus 3 is 26, and 26 plus 3 is 29. So that's pretty easy, right? Okay, that is pretty easy, but how would we use Mathematica to get the same answer? Because some of these problems get really complicated, so it's good to have a programming tool that will help you make things a little bit easier. Okay, we can use the table command. 2 plus 3 times n. N starts with 1 and goes up to 10. In this case, actually 9. 9, because, yeah, we have 9 terms, and then if you include the 2, that's actually... we should actually, you know what? Go from 0 to 9. There we go. 0 to 9. So this is the table command. Okay. So we start, so 2 plus 3n is the expression. N starts with 0. 2 plus 3 times 0 is 2. 2 plus 3 times 1 is 5. 2 plus 3 times 2, well, 3 times 2 is 6, so 6 plus 2 is 8. 3 times 3 is 9. 9 plus 2 is 11, etc., etc. You get the idea. Okay. Now, what happens if I enter a really large number here? Okay, I just see a lot of spaces, right? There's actually a way to change that. You could insert commas if you really want to. I'll explain that perhaps in another video. Okay, notice there are little spaces. There are thin spaces that separate the number into groups of 3 starting from the end. But if you want to, you can change that to commas. Okay, so let's do one more of these. Maybe a couple more. Okay. This sequence, the sequence that lists each positive integer 3 times in an increasing order. Now that's a little bit strange. The sequence that lists each positive integer 3 times in an increasing order. So the first 10 terms are, well, if I'm interpreting this correctly, it would be 1, 1, 1, 2, 2, 2, 3, 3, 3, and 4. Yeah, so that's what they want. They want that kind of repetition. 1, 1, 1, 2, 2, 2, 3, 3, 3, okay, 4, 4, 4, etc., etc. Hold on one moment. Okay, sorry about that. So how would we do that in Mathematica? Well, that could be a little bit tricky. So if we do constant array 1, 3, we have 1, 1, 1, 1. Okay. So you would have to do, see, this is a little bit tricky to do in Mathematica. So you could do something like this. You could do, let me think for a moment. Well, you could do something like this. You could do constant array 1, 3, join constant array 2, 3, join constant array 3, 3, join, and then constant array 4, 3, etc., etc. We could save that to my list, Shift Enter, and then we could simply take the first 10 elements of my list, which would be 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, etc., etc. So actually, we could even define this recursively, perhaps, although this gets a little awkward, but we could, and let me see here one moment. Okay. So we could do this recursively. So what problem is this? This is problem number 81. So we could do prob 81. This is a number. You need that underscore. It identifies the argument. Well, it identifies the n as the argument to a function or a variable. And actually, let me see, n. We're always going to start at 1. We're always going to start at 1. So that should just be 1. If start is greater than n, simply give me back the empty list. Otherwise, constant array start 3 times, join prob 81 and start plus 1. Or 1 plus start, it doesn't really make a difference. Prob 81, let's go up to 10. So we have 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6, 7, 7, 7, 8, 8, 8, 9, 9, 9, 10, 10, 10. Or we could go up to 50. Same idea, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, etc., etc., etc. So let's say I want I want the first 100 terms of the sequence. Well, first of all, how long is this? It's 150. So it's too long, right? So take prob 81, 50, and I want the first 100 terms. Okay? And these are the first 100 terms. Pretty cool, right? So Mathematica is really cool. I think Python and Racket are better than Mathematica when it comes to doing certain things. Mathematica is better than Racket and Python when it comes to doing other things. Okay, it kind of depends on what we're doing. So for certain things, Python is the best choice. For certain things, Racket is the best choice. For certain things, I think Mathematica is the best choice. It really depends on what we're doing. It really depends on what we're doing, okay? In this class, we're going to use a little bit of all three. We're going to use some Mathematica, we're going to use some Racket, we're going to use some Python, and you'll realize that every programming language or every programming environment has its strengths and has its weaknesses. Every programming language is really fantastic at doing certain things and solving certain problems, but can be very difficult to use for solving other problems. Okay, and so you have to, the programming language that you choose is really determined by the types of problems you plan to work on. And in this class, programming is a big deal. Discrete math studies many of the algorithms that are very important in computer science. And it's been my experience that the vast majority of the students who take this class are actually going to major either in computer engineering or computer science or electronics or electrical engineering or something like that. Okay? So, yeah. Okay, guys, I don't want this video to get too long. I think a half hour is good, okay? And that's it. And I'm looking forward to working with you guys this semester. There's a lot of homework to do. Make sure you keep up with the homework. That's really important. Make sure you learn the basics of Mathematica, Racket, Python, please. Don't wait to the last minute. Get started as soon as you can. Thank you, and have a great day.